Hi, algebra students. We are back today and we're going to keep going over graphing quadratics from vertex form. So just some reminders, our LTQ is tomorrow, but we're going to spend the majority of class time reviewing this together. And our test is Friday. So vertex form is the very last thing that we are learning how to do with graphing. And then once we kind of recap that today, we'll keep practicing tomorrow. We'll start reviewing for the test tomorrow, and then we'll take that last LTQ. So a few things we learned yesterday was that we have this equation of a quadratic, a parabola that's written in vertex form. And that is the equation that y is equal to plus or minus a times the quantity x minus h squared plus k. And we can remind ourselves that that plus or minus up at the front that's being multiplied by a is the concavity, whether it's concave up or concave down. That a value is telling us our dilation. So is it being stretched by 3? Is it being compressed by 1/2, right? What does it physically look like? Is it getting wider, or does it look like kind of like a little bit thinner and longer? So what visually are we seeing? And then we have that x minus h that's located inside of the parentheses, and that tells us if we're shifting to the right or left. And then we have that plus k on the outside, and that's telling us if we're shifting up or down. So really, the transformation comes from that vertex, and we know that the vertex of the parent function is 0, 0. So we're really always comparing how does our new parabola look compared to the parent function. So let's go ahead and let's take a look at our first example, which is number 1. We have g of x is equal to negative x squared plus 4. So the very first thing that we're going to notice is that because we have that negative out in front, our parabola is going to be concave down. Now, because we just have an x squared, we don't have anything inside of the parenthesis, we know that our x value is going to stay at 0 in the vertex, so we can go ahead and plot that right away. But then we have that plus 4 on the outside, so we know that our vertex is going to shift up 4 units. So what was once at 0, 0 is now at 0, 4. And we're going to go ahead and plot that point. So 1, 2, 3, 4. Let me zoom in for a second. 0, 4. And voila. Okay. Now, once we are here, we have the ability to plot some points. And if you notice in the directions, it says that we want 5 points, right? So from 0, 4, we're going to go out 1 and down 1. Because it's concave down, to the left 1 and down 1. We're going to go out 2 and down 4, to the left 2 and down 4. And if you wanted to keep going, we could go out 3 and down 9, out 4 and down 16, out 5 and down 25. But we don't have to, because again, we only just want to really plot 5 points. This is just a sketch. And then we can go ahead and draw in our parabola. And voila. So now we're able to answer some key characteristics. First off, if we know that our parabola has a vertex at 0, 4, then we know the axis of symmetry is where x is equal to 0. We know that because there's a negative out in front, our concavity is down. And actually, really quickly, you guys, let's go ahead and plot our axis of symmetry, this dashed vertical line right here where x is 0. We know that because our parabola is concave down, that our vertex is a maximum point. And we know that because our vertex is at 0, 4, our y-intercept is also at 0, 4. I'll use blue, but let's go ahead and star that, because when you have a vertex that falls where x is 0, it is also going to share a y-intercept. That's also the point where the parabola crosses through where x is 0. So those are actually the exact same point. And so this would be an example where your vertex and your y-intercept are the same. And that is how we would graph number 1. Okay, so go ahead and make sure you have everything written down. Make sure you have 5 plotted points. Make sure you have arrows. And then we can go ahead and take a look at number 2. So number 2 looks a little bit different. First off, we notice that number 2 is positive, so it's going to be concave up. But we see that that minus 3 on the inside, which really means that we're going to do the opposite and we're going to shift to the right 3 units. Okay, now that we shift to the right 3 units, we are able to plot our vertex at 3 comma 0. So let's go ahead and let's plot that 3 comma 0. So really the vertex does not shift up or down from 0, 0, but it does shift to the right. So we're moving it 3 units to the right. So from here, because there's A is just 1, there's no stretch or compression, we can go to the right 1 and up 1. We can go to the left 1 and up 1. We can go to the right 2 and up 4. We can go to the left 2 and up 4. And now we have our 5 points to plot our parabola. And again, a sketch doesn't have to be perfect, but just make sure you have arrows, make sure it doesn't look like a V and all that good stuff. So because our vertex falls at 3 comma 0, we know our axis of symmetry is going to be where x is equal to 3. So we can go ahead and plot that solid dashed, sorry, not solid, but that dashed vertical line through where x is equal to 3. Because it's positive, we know that our parabola is concave up, and we know that our vertex would be a minimum point. Now, this is where this example differs from example number 1. In this example, your vertex is actually the same as your x-intercept, but it's not the same as your y-intercept. So in this example, we would need to figure out when x is 0, what is y. So for us, we can go ahead and plug that in. Now, visually, if you just go out 3 and up 9, you should hit the y-intercept. But again, algebraically, if you plug in 0, you should always be able to get that value. So we're going to go ahead and say 0 minus 3 squared. Well, we know 0 minus 3 is negative 3, and we know negative 3 squared is positive 9, and that is our y-intercept, which we want to make sure that we put as a plotted point. And you can go ahead and then kind of like graph that right up there. And then if you need to fix your parabola to make sure it goes through that point, definitely go ahead and do so. But that is how we would talk about example number 2. So if you notice in example number 2, your vertex is actually your x-intercept, and there's only one of them. It does not look like example number 1 where you'd have 2 x-intercepts, and it does not look like example number 3 where we're once again going to have 2 x-intercepts. And so then that leads us to our last and final example on graphing for today. In this example, we see a few things that happen. So first off, because we have that x minus 4 inside the parentheses, we are going to shift right 4. We're also going to shift down 4 because we have that minus 4 on the outside. So that means that our vertex compared to 0, 0 is now going to be at positive 4 comma negative 4. And we can go ahead and plot that point right here. Okay, so from there, we can go out 1, up 1, out 1, up 1. We can go out 2, up 4, out 2, up 4. And then we can go ahead and sketch in that parabola and make sure we have arrows on it. So our axis of symmetry is going to be the equation where x is in our vertex. So that's going to be where x is equal to positive 4. And using a different color, I can go ahead and sketch that dashed line in right there. Okay. We know that because our equation is positive, that our parabola is concave up. We know that that's a minimum point. And now we kind of have to discuss this y-intercept. Because our vertex is where x is 4, if you think about going out to the right 1 or left 1 and going up 1, you could go out 2 and up 4, out 3 and up 9, out 4 and up 16. That's going to be around that area where our y-intercept is going to fall. And we're not going to be able to see it in our coordinate plane, but that doesn't mean we don't know how to find it, right? This is going to be an example where you should be plugging in 0 and then solving for y. So we're going to say 0 minus 4 squared minus 4. And we know 0 minus 4 squared is just negative 4 squared. Negative 4 squared, we know that that is positive 16. And 16 minus 4 is 12. And that is what we want to put in our ordered pair is 0, comma 12. And like I said, that's not going to fall in our range. Okay, if you think about it, that's going to fall somewhere like up here. So if you want to maybe sketch it, go ahead, but you definitely don't have to in an example like this. So on our LTQ tomorrow, you are going to be asked to graph a parabola in vertex form. You are going to be asked a lot of these key concept questions. So please just make sure that you familiarize yourself with the vocabulary. And if you have any questions, please circle them, star them, highlight them, and let's touch base tomorrow when we're back together as a class. All right. The next video goes over some working backwards problems on the next page. So I'll see you in the next video.